So let's solve a few problems and do the rest in class. Okay, let's work on this first problem. Calculate the pH of a 0.020 molar HCl solution. Okay, for this problem, what you want to do is, well, you need to know first whether the acid you're looking at is a strong acid or a weak acid. Okay, it turns out here that hydrochloric acid is a strong acid. Now, what I'm going to write right now, you don't really have to do it for strong acids all the time, but I just want to illustrate here that if, for example, you have hydrochloric acid, okay, and it reacts to form H plus, or dissociates rather, plus chlorine minus. Okay, we can write an ice table for this one. It's ice with air quotes just because this is not an equilibrium problem. Notice that it goes into full completion. Okay, so for this one, that will be I, C, and then instead of E here, let's put and. Okay, so for this one, that will be, we're going to start with 0.020 molar of HCl. We begin with nothing for H plus and nothing for Cl minus. Okay, since again strong acids are fully dissociated in solution, then this one should just be minus 0.020. Okay, and then this one will be plus 0.020. This one will be plus 0.020. That at the end we actually get, in essence, no intact HCl, and we have instead dissociated H plus, that concentration, and Cl as well. Okay, note that this is 1:1. Okay, meaning for every 1 mole of hydrochloric acid, you have 1 mole of H plus and Cl minus formed. It's going to be different, for example, for diprotic acids such as H2SO4. Okay, in fact, that will also be different for this one that we're going to work on tomorrow. Okay, so since the concentration of H plus is this, you can just get the negative log of that to solve for pH. There's going to be negative log of H plus, which is just equal to negative log of 0.020. Okay, again, we need to sig figs in our final answer. For the mantissa rather of our final answer, so this one should be 1.70. There's 2 sig figs in the mantissa. Okay, let's jump to 13.60. Now, what if, for example, you have the pH of a strong acid, okay, and you want to calculate its concentration? Okay, now, based on what we have mentioned earlier, since hydrobromic acid, okay, since HBr is a strong acid, okay, then again, the concentration here as written of HBr is H plus, equal to the concentration of H plus. Well, except for the fact that we're not provided that. However, we're provided a pH. Keep in mind again that we can calculate from the pH the hydronium ion concentration or the concentration of H plus, which is just H plus is equal to 10 to the negative pH. Okay, so this one just becomes 10 to the negative 4.25. Okay, the mantissa here has 2 sig figs, so the answer should have 2 sig figs. So this one should be 5.6. Oops, that's too far. 5.6 times 10 to the negative 5 molar. All right, and then for this problem, let's just calculate, for example, a case in which you have a dibasic base. Okay, so let's do the first problem first and then work on the rest tomorrow. So calcium hydroxide is also a strong base, or is a strong base. Okay, so therefore here the concentration of OH minus should be equal to this one just shows that for every 1 mole of calcium hydroxide, okay, you have 2 moles of hydroxide ions. So here the concentration of hydroxide should just be 2 times 0.12340. Okay, sorry, just counted the zeros there, that's not the numbers, molar. Okay, and therefore the total concentration of hydroxides in solution should be 0.00080 molar. Okay, now that you have the hydroxide ion concentration, we can solve for POH. Okay, POH is just negative log of that value, 0.12380 molar. That just gives us 3.10. Okay, and therefore pH is equal to 14 minus this number, 3.10. That should be equal to 10.90. Pretty basic solution.